Yeah, welcome everyone. So this session will be slightly different than some of the others you have seen. I mean, usually someone stands up here and talks about how to do things right and how great a framework, tool, or whatever is. And to be honest, I'm doing that quite often as well, but I thought, well, let's try a different approach. Let's take a look at all the mistakes and problems we see in so many projects, and let's focus on them and actually take the perspective of someone who might want to harm a project and actually make sure that it's not that successful, and intentionally or unintentionally adds those features to the code base to actually see what kind of harm all of that can cause. And then we, of course, also talk about how to do it right, because without it, it wouldn't be really a conference talk, right? So we spent most of the time in the IDE, and I can hardly see you, but I can hopefully hear you. If you have any questions, just shout at me, and I will do my best to answer them immediately in the talk. So, who am I? My name is Thorben. I'm a freelance consultant, trainer, author, specialized in the Java persistence niche. So I'm spending most of my time with Spring Data JPA, Hibernate, which is usually used as the JPA implementation, underneath Spring Data JPA, sometimes also standalone. And I've written a few hundred articles about that on my website, thorbenjanssen.com. So if you want to stay up to date with the latest developments, or just dive deeper into some specific topics, make sure to have a look there, or maybe even visit my membership site, Persistence Hub. Okay, but enough talking about me. Quick disclaimer before we look at all the things that could go wrong. You can, of course, build high-performance application with Spring Data JPA. I hope most of you have already done that. If not, then you will definitely get some inspiration in this talk on what to improve to actually get a high-performing application. But sometimes breaking things is a little bit more fun than standing in front of a crowd and always talking about what the right way would be, right? So what can we do to actually get a project in trouble? Well, users always love a very bad performance. If you click a button and wait several seconds, that feels great, right? Same with inconsistent results. You refresh a list, and it shows something different to what you saw a second ago, and then you click the button again, and it again shows something different, and you would expect that it's always the same. And another thing that is probably keeping your managers awake at night is loss of data. Losing data is probably the worst thing that can happen to an application. The good thing is it rarely happens if you, well, first of all, if you have backups, but if you don't do anything crazy, it's rather hard to actually lose data unintentionally with Spring Data JPA. But there's a way you can do that, and we will take a look at that at the end. So let's start with slow applications and switch to the IDE, because there we will spend most of the remaining 40-something minutes. So typical example, we have an author entity and a repository for that, and we fetch an entity from the database, and then we iterate through it and do some complex business logic, right? Like printing out the author names and the titles of all their books. So let's run this and see what happens. If we look at the output, we will see the most loved exception in the Spring Data JPA space, and that is the lazy initialization exception. Who has seen this exception? Oh, come on, stop lying. Every one of you saw that, right? I mean, if you haven't seen a lazy initialization exception, you haven't used Spring Data JPA. This thing shows up every time. And the problem is always the same. We fetched an entity somewhere up here, and then outside of our transactional context, we actually lose the connection between the entity and the session that fetched that entity from the database. And due to that, the lazy fetching, so the initialization of this list of books, no longer works. So if you ask Google what to do, you find lots of replies, unfortunately, still a few questionable ones, that tell you just switch fetch type lazy to fetch type eager. Well, sure. Without lazy fetching, we don't have any lazy initialization exceptions. Makes sense, right? So why is this building so long? Come on, I only changed the fetch type. It's not that hard. Let's try again. Would you please build this? Pretty please? Great. So what solves all problems? Restarting the IDE. Go on, stop this. Thank you. Are you kidding me? Okay. So, IntelliJ, are we back? I know, it's almost 5 p.m., but it's not that late. It's fine to work at 4:45. Well, while IntelliJ is thinking about this project, which really isn't that complex, let's talk about what I actually changed. I changed the fetch type from lazy to eager to tell Hibernate, which is underneath my Spring Data JPA as in every Spring Boot application, to actually fetch the books relationship whenever I fetch an author entity. And do you see that? It ran. Great. So what did I do? I changed the fetch type from lazy to eager, and we ran the test case. And as you can see here, there's a green check mark, so everything worked fine. And if you take a first look at this log output, you might say, this is exactly what I wanted. I mean, I know I need my author with ID 1 and a list of books. So how do I want to fetch all of that? In one query, of course. And that's exactly what happens here when we change the fetch type to eager. But it's not that great if we run the next test case, which gets all authors and just wants to print out the first name and last name. Because then we have a query that fetches the author. Yeah, fine, I need that. And have a bunch of select statements that fetch the books. 6 in this case, because my database only contains 6 authors, and that means I executed 6 additional queries on my local test system, which is probably not that recognizable, but if you deploy it to production and you get back a few 100,000 or even more authors, then this will for sure cause severe performance problems, because you now have an n+1 select issue where you trigger an additional query for every one of these n authors we actually got from the database. So this is the most common performance issue that you can cause with Spring Data JPA or any JPA implementation in general. And I guess most of you have seen this problem, right? I mean, it's very common. And I just thought, okay, you can't do a presentation like this without running into a lazy initialization exception and causing an n+1 select issue. So what are we actually supposed to do here? Fetch type eager obviously wasn't a great idea. So let's try something else. A much better approach would be to actually write a query and tell our JPA implementation that we would like to get the author with an initialized books relationship. And it's that here. Left join fetch tells Hibernate to fetch the books relationship, or Eclipse link if you're using Spring Data JPA with Eclipse link. And now we got the same result as we had before with the eager fetching, but now it's because we have a query that tells our persistence provider, okay, now I need that relationship, and I get everything in one query, which is much more efficient than the n+1 issue we had before, especially because if we now fetch all authors from the database down here, we still have lazy fetching for the books relationship. And fetching the books is good enough. Just have a query here. Also see that here in the Hibernate statistics that we just executed one JDBC statement. Maybe a quick recommendation: if you're using Hibernate, then you should set your system properties, Spring JPA properties, Hibernate generate statistics to true. I usually do that actually as a system property, just hibernate.generate statistics on my development system, because then I'm not at risk of shipping that to production, which would actually not be that great, because it slows down production system if we collect statistics, right? So if we do that, we get this output at the end of every transaction. And this gives us a pretty good overview of what kind of things we actually did. So the first 2-3 things we just had a look at were probably known to most of you. So let's take a look at something else. I get a book from the database and decide that one of the authors actually didn't work on that book, and that I want to remove the author from the list of authors of that book. So what would we expect here? This is definitely something that we could write in our code, right? No one would be suspicious here, especially not if we take a look at our book entity, where we see that authors are modeled as a many-to-many relationship of type of a list. I'm probably not the only one who learned that lists are a great collection type when they started to learn Java. The overhead is extremely low, it's efficient, it's nice. So using that as a many-to-many attribute is obviously a good idea. Well, getting the book from the database and removing the one author from the list actually triggered 7 JDBC statements. And with some of them we actually have just delivered, but the strange part of this here, we delete all relationship records between authors and books from for this book with the given ID, and then Hibernate reinserts 3 records into that relationship table. Why did it reinsert something? I mean, if we look at the test case, I would just removed something here, right? Well, this is actually not a Spring Data JPA issue, it's a Hibernate mapping issue. And it's caused by modeling a many-to-many relationship as a list. This is called a bag in the Hibernate world. So it's an unordered collection type that's allowed to contain duplicates. And Unfortunately, for many-to-many relationships, Hibernate handles those very inefficiently, and you can easily change that by switching it to a set which no longer allows duplicates and enables Hibernate to actually manage the relationship much better. So the question you have to ask yourself, of course, is your relationship allowed to contain duplicates? In most cases, when working with a relational database, that's not the case. I mean, especially in this case, why should I add the same author twice to a book? Having the relationship once is more than good enough, right? So I don't need duplicates. I can simply switch that to a set. And now Hibernate does that, does the statement that we actually expect. So we have a delete statement from the book authors table that just removes that one relationship record. And this is something that actually hard to spot if you don't know what's going on. Because, well, as I said, we all probably learned a list is a great collection type. And I agree with that, just not when modeling a many-to-many relationship between two managed entities. In that case, a set is the much better approach. Let's take a look at another example. We have a simple query here, and we just learned that we want to use joint fetches when we know that we need relationships in our business code, right? So I do that here. I know I want to print out the title of the book and the list of authors and the reviews that I got for that book. And to have this test case fail, I need to actually switch back the stuff that I just changed, because this shows you another reason why we should use the set as our many-to-many relationship type. Wait a second. Both have to be a list. So a moment ago, I mentioned that a list is actually called a bag. And we see that, again, when we now run the test case that executes a query that fetches a book with authors and with reviews. So it joint fetches two-to-many relationships, each of them modeled as a bag. And this then triggers a multiple bag fetch exception, at least if you're using Hibernate. I mean, Spring Data JPA integrates your JPA implementation into the Spring stack and gives you the repositories that we hopefully all like. But that means we live and die with the implementation that we actually use for JPA, and that means we have to be aware what's underneath Spring Data JPA and how that actually works. So some of you probably have seen the multiple bag fetch exception, and it says, well, I can't fetch multiple bags simultaneously, and you now find basically two kinds of recommendations how to solve this. One is, don't fetch more than one-to-many relationship, because, well, it causes this exception, and when you fetch too many relationships, your result set size grows massively, because now we get each book multiplied by the number of their reviews, multiplied by the number of their authors in the result set size. And this quickly multiplies up to several million data points that we are selecting, if our too many relationships are too big. So therefore, sure, you could argue fetching fewer to many relationships is actually a good thing, but it's not really an issue of too many relationships in general. It's a problem that at least one of them is too big. So I rather would recommend, okay, take a look at your domain model and your actually application domain. Make sure that you don't join fetch a huge too-many relationship, because fetching one that just contains 10 records is totally fine. And use a set instead, without modeling the many-to-many relationship as a list. You actually don't have a bag, and that means you can't get a multiple bag fetch exception, and that makes the entire handling here way more efficient. But let's first take a look at the query. So we now saw here the query is huge, right? So a bunch of columns. We join from book to book authors to author to review, just because we join fetched a few relationships. So common idea now is let's just add caching, because fetching all that data is expensive. Better not do it. Let's say we cache the book, we cache the author, and let's cache the review as well. And let's run this test case twice and see how much better it all gets by activating caches. Who uses caches? Well, that's good. Not that many. I mean, it's not good because I don't think that caching is in general a good feature. It's because it's a little bit tricky to actually get a performance benefit out of it, because let's take a look at the output. We ran the query twice up here to get a list of books and print out everything, and all of these entities are cached. And down here, we do the same again. And again, all these books and authors and reviews are cached, right? And we see actually here that we put quite a few of them into the second level cache. But if we go down here to our second iteration, there starts the second iteration. We run the same query again. And we again put 6 objects into the cache. So we didn't get anything out of this caching feature right here, except for spending, well, quite some time, about probably 4.5, 5 million nanoseconds on something we didn't get anything out of it. Who has an idea why? No one? Can you repeat that? Cache needs to be validated. Invalidated. It would be invalidated if I do something that modifies any of my data. But I don't do that. So yes, cache invalidation can be an issue, but not here where I'm just reading. The issue is actually something else. The issue is this. Probably easier to read if I don't highlight it. The issue is that the second level cache provided by any JPA implementation isn't used if we write our own query. With that, 90% of our use cases can rely on second level caching in this form, right? We mostly execute our own queries. So what else could we do? Well, if normal caching doesn't work, then maybe query caching. We could activate Hibernate's query cache for this statement, and we run this thing. Let's see if that helps. First iteration executes the query. Well, obviously, can't be anything in the cache. We now have self-input operations into the cache. That's more than before. Sounds good. And now we have a hit. Oh, that's great. So second iteration gets all the data from the cache. But with this, you have to be very careful depending on the Spring Data JPA, and with that, which Hibernate version you are using. If you're using Spring Data JPA 2, which uses Hibernate 5, all the entities you are returning from that query statement have to be in your second level cache. Otherwise, Hibernate will resolve them in the second iteration via a specific query for each of those entities. And query caching, and that doesn't happen with Hibernate 6 unless you change your query cache layout to shallow. So that is something that Hibernate 6 introduced. In Hibernate 5, the query cache only contains references to entity objects. And Hibernate then uses that reference to look in the first level cache, to look in the second level cache, and if it's not there, then goes to the database. That was an issue with Hibernate 5 quite a lot, because teams activated query caching, saw, oh great, the query result gets cached, and that query unfortunately returned 50 entities. And after that, we saw 50 select statements in the log file fetching the entity object one by one. So not caching the query result initially would have actually been better, because we would have just run one query instead of 50 of those. So the Hibernate team in version 6 decided, okay, let's change the layout of our cache, and instead of storing entity references for query results, let's just store the entire entity in the second level cache, because we fetched that data anyway, we have it, just put it there. And that was the default in the beginning in 6, and then people started complaining that the query cache that worked great for their Hibernate 5 application now massively grew in size, because instead of a long that previously was stored in the query cache, we now stored 50 fields for each entity reference. So they decided, okay, let's change the query cache, or make the query cache layout shallow. No, change the query cache layout and introduce an option shallow that represents version 5, and introduce full, that is the new default in Hibernate 6, that stores the entire entity object in the cache. So this is one pitfall with the query cache. There's a second one, and that is the invalidation. So whoever shouted cache invalidation a few minutes ago, yeah, cache invalidation is always an issue with caches, and especially with the query cache, because now every modification on the author, book, and review table will invalidate that query result. Because as soon as you change anything in the data in one of these three tables, Hibernate has no clue if the query result is still valid. And that means you can only use it for basically static data. That makes query caching an interesting feature, but not really the solution to the problem here. So we either stick to the query with joint fetch clauses and fetch those three entities, or the entity with the two sets of other entities, or we actually take a look at a query projection. So you probably all know interface projection with Spring Data, right? Who doesn't know it? Okay, the idea is simple. You define an interface with a few getter methods, and if you then use that, let me close a few things here. If you now use the book author name interface as the return type of your query, or of your repository method, then Spring takes a look at the entity that's referenced in the repository definition and says, okay, if my interface has a getTitle method, then I have to have a title attribute and a getter for that here on the entity. We have that. And this works great. Let's comment out that for a second. And yeah and no, I just removed that. So let's do this. and run the test case. So in this case, IntelliJ really hates me today. So what I actually wanted to show you is that the query that Spring Data JPA generates here only selects the title field from the, let's see, does that work? Probably not. Yeah, no. It worked once, right? Let's try it again. So what Spring Data JPA does when we use an interface projection is it generates a class that implements that interface and then just selects the columns necessary to initialize this, this interface up here. And this is much more efficient than fetching entities for basically two reasons. First of all, I'm not selecting the entire entity, in this case just one column from the table, which is obviously better than selecting 50 of those. And the DTO projection is unmanaged, which means it doesn't slow down the commit and the dirty checks before the execution of queries. So using interface projections in general is a great idea. But usually it's a flat data structure. So we're mapping one record in the result set to one DTO object. And what we quite often would like to have is something like this, where we have a getter for the authors relationship, and there we get back a list of author names because we know that we don't need the entire author object, we just need a first name and last name, right? So get authors is a method somewhere here, there on the book entity, and Spring then maps the author interface, the author entity to the author name interface. So if we now run the same query with the more complex projection that contains actually a list, we would expect that we see the same as before, right? We would expect we have a query that selects the title of the book and maybe the names of the authors, but just first name and last name, because these are the only things we need for the author name interface here. Well, unfortunately not. What we have here is we now have a query that fetches the entire book entity from the database. And didn't I change the book author name? Book author name. Okay. Get authors. Let's just get the size and do something that actually accesses the relationship. And this is what I wanted to actually show. So the book author name interface here now looks like an efficient projection that is not managed by the persistence context, and that just represents the title of the book and a list of author names. But if we look at what kind of queries Spring Data JPA executes, it looks totally different. Spring Data fetches the entire book entity and then fetches the author's relationship for that book from the database. So a bunch of author entities. And if we would have any relationships there that we access in some way, Spring Data would fetch that as well. So please don't use any collection types on your interface projections. It looks great, it feels good, it performs horribly. Because instead of the efficient, unmanaged DTO projection, we actually get an entity projection with all its overhead that we don't need for these read operations. What should we do instead? Well, we could do something like this. We define an interface with, oh no, one step back. What you could do instead is you could, if you really, really want to keep this book author name interface with a list of authors, you should at least use a query that fetches the book entity and join fetches the two relationships to authors and reviews. It's still not great, because we are still fetching the book entity, the author entity, and the reviews entity, and we just need 3 fields, right? The first name, the last name, and the title, so it's totally unnecessary to fetch all of that. But now we do it at least in one query. So still an overhead, not that much compared to the approach before. What would be better is if you actually define a simple interface with the title, a review count, and author names. The challenge now is that this doesn't match the book entity anymore. So we have to put a little bit more work into the query statement, and I did that here. I'm selecting the title of the book and set the alias title. That's important for the automatic mapping. Then I use a database function to actually aggregate all these strings of the authors. So this expression here tells my database, which is a Postgres database, to concatenate the first name with a blank and the last name, and then aggregate over the entire list of authors that are linked to the book, and aggregate them and put a comma in between. And then I count the reviews. The nice thing that Spring Data JPA now provides us here is that we can set the title as an alias, the author names as an alias, and the review count as an alias. And you now probably already guess what's happening. This matches those getters here. And if we run this query, Spring Data automatically executes the query and maps our result set based on those aliases, which is quite nice. That means as long as you are using an interface projection, you can simply just put a few, where is it here? A few aliases into your query statement, and Spring automatically maps that to the fields of that DTO projection. And by that, you can map any query result to any DTO projection without any additional code or work. And you could, of course, also cache this. I skipped that. You always saw the query cache. The only thing you have to do is add a query cache, add a cacheable hint to the repository method. So what did we see? We saw that it is quite easy to add things to our application that look fine, but actually cause issues at runtime. And what all those issues have in common is that they get worse when you deploy it to production, where you have a bigger database with more data, and that means all those problems just scale up in size, and something that might have been okay-ish on your test system with a few dozen records starts to become a huge issue if you run that against a database with 100,000, several millions, or whatever amount of data in it. So please make sure that you have the fetch type lazy on all your relationships. It's the default for too many's. For too one, you have to set it yourself. Please use case-specific projections. With Spring Data JPA, that's extremely simple. If you just want to read data, the best thing you can do is define an interface, like we just did, but a simple one. And let Spring Data map the few columns that you usually need in your read operations to the generated implementation instances of that interface. And then you can work with that without any overhead. But keep it simple. So no relationships in those interfaces, no expression language, nothing. Just a set of few basic, simple getter methods. And we also saw that mapping many-to-many relationships, as I said, is actually an issue. Okay, so that was the main part that we could use or should be aware of to avoid our problem getting in trouble. Or, if you actually want the project to fail, just make sure you put in all of this. What else can be an issue? Well, inconsistent or unexpected results can be quite problematic. And here's a common example of that. We just had a look at joint fetches, right? And so it's great to get an author with books, or just the books they've written, in one query, which is obviously better than executing multiple of those. But what happens if I say, okay, I want the author with all their books who've written a book with a given ID, or title, or whatever? Well, then we would probably just start the from clause on the author entity, left join fetch the books, and limit the books by primary key. Let's see what happens. Test case is green, great. Max wrote book 2, Maria wrote also book 2, looks great, right? Well, it might look okay here, but that changes if I switch the query statement and rerun the test case. So what's the difference here? Now, instead of using a left join fetch up here and using that also in the where clause, I use two joins. One normal left join that I use for my where clause, and a left join fetch to initialize the relationship. And if we now look at the test output, we see that Max and Maria not only wrote book 2, both of them wrote 3 different books that was not visible before. Why not? Because we just joined once from the author to the books and limited that list of books to the one with ID 2, which is okay to filter the authors that worked on that book. But it's not okay if we also tell Hibernate to initialize the books relationship completely. So a join fetch tells your persistence provider you want a fully initialized list of books. And that means you can't use that in any predicates in your where clause. Please make sure to always join it twice, once for the where clause, once to tell Hibernate or Eclipse Link that you want to fully initialize the list of books. The good thing is, in most situations, limiting the result set here, in the first wrong approach, just causes issues in the use case that executes this query. There are just a very few special situations, like this many-to-many list handling that we saw earlier, where this query up here could actually even result in losing data. What else is something that could result in unexpected results? Well, you probably have heard about the modifying annotation. It allows you to write your own update or delete statement and execute that against the database. This is great if you want to do a mass update on lots of records, if you want to delete a huge data set, stuff like that. And if you do that, then there's one thing you have to be aware of. In this example, I first get all authors from the database. Then I execute my update statement. I get those authors again, and you would probably expect that you now see down here that, well, upper first name, upper last name, that the first and last name of all those authors I print out here are in uppercase, right? Well, you would expect that, but it isn't. Even though we executed an update statement that clearly changes the first and last name of every author to uppercase, and then we select the authors from the database, so they should be in uppercase, right? Well, they are in the database. But the problem is that up here in the beginning, this find all fetched all author entities from the database and put them in the persistence context. These are now managed entities. And if you then execute this update statement, then Hibernate ignores the persistence context, goes directly to the database, executes the update statement, and nothing happens to the entities. If you then execute the next query to find all authors, Hibernate goes to the database, asks it for all authors, gets back the result set, iterates through it, and recognizes, oh, this is author with ID 1. Let's first check if there's a managed author entity with that ID. And if there is, it gets the object from the persistence context, which means you don't see the change in the database even though it was actually performed. And to handle all of this, there are two flags that you can set on, flush automatically. There are two flags that you can set on your repository method, clear automatically and flush automatically. You always have to set both. Flush tells your persistence provider to send all update statements to the database. So perform a full dirty check on your entities, send that to the database. And clear automatically then clears your persistence context so you have no longer any managed entities. So if before executing the update statements, we actually get rid of all managed entities, we can then fetch the author entities down here again, and now we get the expected result. So to be clear, we didn't have any real inconsistencies here. It just looked like that because we didn't get the modification that we just performed on the database. But depending on what your business code does, it's almost as bad as having a real inconsistency because you will work for the rest of your transaction on outdated data. A quick one, if you have bidirectional relationships, please always update them on both ends. It's required by the specification, and if you don't do that, if you just remove a book from the list of books on the author, then you see here that we don't execute any delete statement. Right? A select, a select, a select, another select. No removes, even though I removed the thing here. Why is that the case? It's the case because we have a many-to-many relationship with map by on this relationship. And it's managed and defined on the book side. You have to remove it on both ends, and in most cases, we do that by introducing an additional method on one of those entities that actually takes care of this. So to avoid inconsistencies, please make sure to keep joins and join fetches separate. Don't forget your caches, and always update both ends of the relationships. Especially the last point is something that I see as in so many projects as a mistake. And it there totally depends on which end of the relationship you update. If you just update the referencing side, as in the example that I just showed you, nothing happens to the database. And if you do your modification on the owning side of the relationship, the record gets removed in the database, but it doesn't show up in your current persistence context, so you might work with outdated data. Last and final thing, lost data. Let's play around with cascading. Who loves cascading? Yeah, it's scary, right? So the idea is we cascade a delete operation, for example, from the author entity to the books, because we say, well, when we remove authors, we also want to remove their books. And, well, if we remove a book, we probably no longer need that author, right? Oh, bad idea. This is the last example for a reason. Because when this thing is done, my database is empty. Now the cascade operation bounces between the author and the book table, because we cascade it from one author to all their books, from each book to all their authors, and due to that, we here get first dozens of select statements, but down here you see it. We are deleting lots of data, even though I just wanted to remove the author with ID 1. It's a never-ending list of delete statements. It bounces back and forth until the database is empty. So please, when working with cascading, especially with cascade type remove, make sure that you only cascade from a parent object to a child object that shouldn't be able to exist without its parent. That's the situation for which the cascading was actually designed. Okay, and that's it. If you want to play around with the examples, you can find the QR code to the repository here on the slide. If you think that you want to learn more about Hibernate, Spring Data JPA, any other Java persistence stuff, then make sure to check out the Persistence Hub. And, well, that's it from my side for today. Thanks for joining the talk. If you have any questions, you can find me in a minute in front of the stage, and I will be here rest of today and tomorrow. Thank you.